Hello students, in the last session we have discussed about the R2 to R digital to analog converter in the number into the convert into the digital numbers. Here in this session I am going to explain about the what is analog to digital converter. Means that one the converts the used to change the analog signal to the digital is known as the digital converter or ADC converter. This converter is one kind of the integrated circuit or IC that converts the signal directly from continuous to discrete forms. Means, for example, I'm going to continuous signal into the discrete forms. Means that one, it is the analog is in the signals, it is a continuous form, it converts into the discrete forms. It converts into the discrete forms for that one. That is the use of the use of the analog signals to the it is a continuous signal. I am going to in the discrete level of the signals can be used it in the digital systems, that is call it as analog to digital converters. We can use the many of type of the ICs to represent this one. This is the type 2 uh, IDC can be expressed in A to D ADC or A to D. The inverse function of DAC is nothing but ADC is the analog digital converter symbol shown in the figure. This is the symbol of that one. I am going to converter. This one is a converter for that one. I am going to explain about this block diagram. The process of converting analog signal into the digital done several ways. The ways are there. There are the different types of the ADC chips available in the market from different manufacturers like ADCO 8XX series, and so a simple ADC can be designed with the D is a number of the output, that one D1 2 raised to minus 1 plus D2 2 raised to minus 1, and D3 is a 2 raised to minus 3, like n terms it is a Dn into 2 raised to minus n. MSB is a D1 and Dn is a LSB, least significant bit and the most significant bit can be expressed, right? In this block diagram, ADC is shown below, which is includes the sample or hold quantized in the encoder process of ADC. Means that one I am going to explain about 3 to 8 bit 8 to 3 bit encoder. Have you seen that one? Have you seen that 3 to 8 to 3 bit encoder, and an NAND gate we have used that one encoder, right? At the same way we are using the n number of the inputs, we are giving output like that, we can get it in the analog digital to uh, analog to digital converter, right? In this ADC can be used like that one. Yes, the first analog signal is applied to the first block, namely sample. Wherever it can be sampled at the exact sampling frequency, the amplitude value of the sample, like the analog value, can be maintained well held within the second block, like hold. Here the hold are a EOC, it is there one. This is the reference voltage start and AOC, it is there one. Yes, this is the first sample amplitude of the sampling, like the analog value maintains the well held second block like a hold. The hold sample can be quantized into the discrete value through the third block like the quantize. Finally, the last block like the encoder changes the discrete samples. I'm going to explain this one is these lines are there na. This is the D1, D2, D3 and the Dn. These are the lines of the digital values in the binary numbers. Means that one. What is the sample? What is the hold? What is the quantize? What is the encoder? Can be used that one. Sample block analog signal can be sampled at the exact several times. Means that one, if you are giving the input in the analog signal, sample, it will check. The first number will check. It converts correctly or wrong. That will sample will take that one, we can continuous. If it hold, if it is the second block is a hold, doesn't have any function, ಅಲ್ಲಿ ಯಾವುದಾದ್ರೂ ಫಂಕ್ಷನ್ ಇರಲಿಲ್ಲ, ಅಲ್ಲಿ ಏನಾದರೂ ತಪ್ಪಾಗಿತ್ತು ಅಂತಂದರೆ ಇಟ್ ಕ್ಯಾನ್ ಹೋಲ್ಡ್. Quantized, the third block is a quantized. The main function of the convert the amplified, it is a correct, it is a high, it is a low, it will correct, and then it will quantized convert. The final block is a ADC's encoder. Yes, it is the encoding the number after quantization. It is a correct answer. Yes, encode that one. The form of the binary, we know that one digital device works by the using the binary signals, so required to change the signals from digital to binary with the help of the encoder. ಮೀನ್ಸ್ ಬಂದಂಥ ಆನ್ಸರ್ನ ಎನ್ಕೋಡ್ ಮಾಡಿ ಅದನ್ನ ಬೈನರಿ ಕನ್ವರ್ಟ್ ಮಾಡಿ ಕಂಪ್ಯೂಟರ್ಗೆ ಯಾವ ಥರ ಲ್ಯಾಂಗ್ವೇಜ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಆಗುತ್ತಲ್ಲ ಆ ಥರ ಕಳಿಸ್ಕೊಡ್ತದೆ. ದಟ್ ಈಸ್ ದ ಎನ್ಕೋಡರ್ usages of the conversion of the analog to digital converter. The main features of the ADC are sample rate and the bit resolution. And sample rate and the bit resolutions are the very important role to play in this session. A sample rate, the ADC is nothing but the how fast the ADC, how it can fraction of seconds, how it will take the very less time duration. Yes, can convert the signal from analog to digital. Bit resolution, nothing but the how much accuracy. If you want to purchase any material in the market, how can you check that one? Cost. Yes, then how many days it will come, means expire date, can we see that one? And how much will give the, for example, if you purchase the mobile, you can see the camera and battery capability and RAM. Can we check this one? Accuracy, how much it will come or not, you can check that one. Sample, your friend will purchase that one, how it comes. You can take all those links at the same time, you can use that one. One of the major benefits of the ADC converter is the high data acquisition, right? Even the multiplexed input with the inversion. Demultiplexer and the mux and demux, you have seen that one. Yes, at the same time like that one. Yes, the ADC converter ICs that a sensor becomes the more accurate, faster and dynamic characteristics, high performance, high linearity, excellent signals, ನಾಯ್ಸ್ ಇರಬಾರ್ದು, ಯಾವುದೇ ಕಾರಣಕ್ಕೂ ನಾಯ್ಸ್ ಕಡಿಮೆ ಇರಬೇಕು, ಜಾಸ್ತಿ ದಿನ ಬರಬೇಕು, ಇಟ್ ಈಸ್ ಫಾಸ್ಟ್ ಆಗಬೇಕು ಸಿಗ್ನಲ್ಸು, ಆಮೇಲೆ ಈಸಿ ಟು ಗೆಟ್ ದ ರಿಸಲ್ಟ್. That is also very important. A variety of the applications, ADCs, measurements of the control system, industrial instrumentation, communication system, and other sensory based on the systems classified in the ADC based on factors like performance, bit rates, and power cost. These are the applications of the ADC. Analog to digital conversion process. How does this process work? Yes, there are the many methods to convert the analog signal into the digital signal. These converts find the more application and intermediate device. There are the many of the types are there to convert the analog signal into the digital signals. Okay. They convert the signal from analog to digital form. Display output on LCD, liquid crystal diodes, through microcontroller. The objective of an A to D converter is to determine the output signal words corresponding to an analog signal. Now we are going to see an ADC of 0804. It is a IC number. It has a 8-bit converter. Yes, 5 volt of the power supply, it is that one 8-bit converter. It can take only a one analog signal as input. This is the graph of that one can be used to digital converter in the 2-bit converter it is. It is a 2-bit converter. 00011011. Analog to digital converter for the signal. The digital output varies from 0 to 255. ADC needs a clock to operate. The time taken to control the analog to digital value depends on the clock source. An external clock can be given to the clock in pin number 4. That is a IC, it depends on the suitable for the RC circuit. It is the internal clock pin, it is 2. It is the IC number, it is a 804 pin. They can expressed in the use that one. It is a 00011011. This is the number of 0 1 2 3, like that one can be used that one. This is the graph of the um, digital to analog process. Analog to digital converter samples analog signals each falling in the rising edge sample clock in the cycle. ADC gets analog signal measured in the converts into the digital value. Can we take the small analog signal here? It is a n bit converter 0001 02 B2 B3. It is a higher. Last bit is a nth bit 000001. It is a 3-bit converter. Analog signals you are giving like that one. You can take the linearity full scale. Yes, this is the way to draw the graph of that one. Like a DMUX, one input, one input, many outputs. ADC is a two factors determine the accuracy of the digital value capacitors. Original analog signal, these are the quantization level bit of the rate sampling rate. Below figure, it can be 3-bit ADC used to convert the analog signal. Assume that 1 volt signal has to be converted from 3-bit ADC as shown in the figure. This is the 1 volt. Here the voltage, it is digital output, and this is a voltage analog input signals. This is the signal. Assume that the 1 volt signal has to be converted from digital to by using 3-bit ADC as shown below. Therefore, a total of 2 raised to 3 8 divisions are available in producing the 1 volt of that one. 1 by 8 8 bits are there. ಇಲ್ಲಿ ಹೆಂಗಂದ್ರೆ 3-bit converter. How many numbers? 000, 001, 00, 010, 011, 100, 101, 110, 111, 1, 2, 3, 4, 5, 6, 7, 8. 8 bits are there. 8 bits are there. 8-bit number can be used that one. 8-bit number can be used at the first number is 1 by 8, 2 by 8, 3 by 8, 4 by 8, 5 by 8, 6 by 8 can be continuous that one 8 numbers are there. It is in the linear line. This is in the approximation comes like that one. Yes, if we increase the bit rates like 6, 8, 12, 4, 16, 14, 16, etc., we will get better precision of the signal. Thus, the bit rate or the quantization gives the smallest output changes in the analog signal. Value that results from a change in the digital representation. Analog signal high, low, that will give that one. It will convert into the digital numbers. It can be shown in the like this way of the conversions. Yes, suppose the signal is 0 to 5 volt of the 804 IC and you have used 8-bit ADC, then the binary output is 5 volt. 256 means For example, 256 means 2 to the power 8, 2 to the power 8. Yes, 256. And for the 3 volt is the sample. For example, how to calculate the D out? Output ಹೆಂಗೆ calculate ಮಾಡೋದಂದರೆ D out equals to 2 raised to 8 into 3 divided by 5 volt. 3 is what? Can we use it? 256 into 3 divided by 5 volt, it is a 133. Can we get the D out? Can we get the D out for this one? Accuracy of the result. The 133 shown below. Here the output 3 volt, and for the 5 volt battery it is there. I am giving the 3 volt for that one. We can get the output like that one. These are an absolute changes of the misrepresenting the input signals. That is the factors, and this is the waveform of that one, input waveform. This is in the discrete form. This is the high and low. This one is a sampling rate. Yes, this one is a factors can be used. ADC performs can be evaluated through its performance based on the different factors. From that, the following two main factors are explained below. Yes, SNR, signal to noise ratio. Yes, reflect on the average number of the bits without noise any particular sample. This is a sample. Bandwidth, the difference between the higher frequency and the lower frequency. ADC, in ADC determine the estimating the sampling rate. The analog source can be sampled per second to produce the discrete values. These are the discrete values. These are the discrete values. Yes, this is the way to identify the one. Types of analog to digital converters. There are the many types of the dual slope A to D converter, flash A to D converter, successive approximation A to D converter, semi-flash ADC, and sigma delta ADC, and pipeline ADC. One more, it is there one. It is a counter ADC. Yes, this is the types of the ADCs. First, we have to discuss about this dual slope ADC. Dual slope ADC, it is the circuit that can be explained in this. This is the V in, and this is the V reference. Yes, this is the V in and this is the V reference. This one is a resistance. This one is a capacitor C. This one is a op amp of the comparator. This one is a one more op amp. This one is a output line. This is the clock control logic system. This is the clock of the counter clock output buffer. Otherwise we can get it in that one. We can use the logic diagram for that one. Can we use the dual slope analog to digital converter? Can we use it like that also? This is a capacitor. This one is the out. This is a output can be used. N bit counter into the control circuit. This is also you can use that one. This control circuit comes here. That is a control system. Here you can connection here. Yes, let us see that one, what they have given. Then afterwards I will explain it briefly. Let us see that one. In this ADC converter, comparison voltage is done related by using the integrated circuit. Resistors and the capacitor form operational amplifier combination here. By the set of values we reference, this is the integrator generates a sawtooth waveforms. On its output form 0 to values V reference when the integrator waveform is started. Integrator waveform is counter is started here. Counter is started here. The counting from the 2 raised to n minus 1. 2 raised to n minus 1. The counter starts ಅಂದರೆ ನಮ್ಮ ಕೌಂಟರ್ ಸ್ಟಾರ್ಟ್ ಆಗೋದು 2 ರೇಸ್ ಟು ಎನ್ದ ವ್ಯಾಲ್ಯೂ ಇಂದ -1. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ 6 ಇತ್ತಂತ ಇಟ್ಕೊಳ್ರಿ, ಸಾರಿ 8 ಇತ್ತು ಅಂತ ಇಟ್ಕೊಳ್ರಿ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಸಾರಿ 7 ಔಟ್ಪುಟ್ಟಲ್ಲಿ 7 ಬಂತು ಅಂತ ಇಟ್ಕೊಳ್ರಿ. ಅದೇನಾಗುತ್ತೆ 2 ರೇಸ್ ಟು 3 -1 ಬಂದಂಥ ವ್ಯಾಲ್ಯೂನೇ ಔಟ್ಪುಟ್ 7 ಆಗಿರ್ತದೆ. ಎಸ್, ದಟ್ ಈಸ್ ದ ನಂಬರ್ ಕೌಂಟರ್ಲಿಂದ ಆಗಿರ್ತದೆ, 8th ನಂಬರಿಂದ ಆಗಿರ್ತದೆ. ಈ ಥರ ನಂಬರ್ಸು ಬರ್ತವೆ. ವೇರ್ ದ ನಂಬರ್ ಆಫ್ ದ ಬಿಟ್ಸ್ ಅಂದರೆ 7 ಬಂದದಂತಂದ್ರೆ 3 ಬಿಟ್ ಆಪ್ರೇಟರ್. 7 ನಂಬರ್ ಬಂದದಂದರೆ 3 ಬಿಟ್ ಆಪ್ರೇಟರ್. ಅದೇ 8 ಬಂದಿತ್ತು ಅಂದರೆ 4 ಬಿಟ್ ಆಪ್ರೇಟರ್. ಇಟ್ ಡಿಪೆಂಡ್ಸ್ ಆನ್ ದ 3 ಬಿಟ್ ಆಪ್ರೇಟರ್, the up to 3 bits. 4 bit operator, it comes the 4 bit operator. Yes, this is the digital output for this counter. When the input voltage Vin is equal to the voltage of the waveform, then the control circuit captures the counter value, which is the digital value corresponding to the analog input value. This dual slope ADC is a relatively medium cost and the slow speed device. Yes, it is a slow speed device. I am going to explain this one. And V reference is, I am going to explain about this one. Yes, V is greater than V reference. Will that one, it is the high for that one. V is less than V reference, it is a 0 for the op-amp. Op-amp is 0. And one more thing, it is the clock, it is there. Here the clock, here clock it is there. Yes, n is number of bits. This n is a number of bits. Yes, n is a number of bits. The t equals to, yes, this is the counter will starts on that one. Counter will starts on that one. The counter will starts on that one. It is a 2 raised to n minus 1 into time clock. It is a t. T is a clock period. The total clock period equals to, the total clock period equals to 2 raised to n minus 1. The total clock period equals to, total clock period equals to 2 raised to n minus 1 into t plus the t1 plus the t1 at the continuous like that one. T1 equals to 2 raised to n minus 1 into 2 raised to n minus 1. It is a clock time into t. Into t can be used that one. At the 2 can be used that one plus t1 equals to, what is that, 2 raised to n minus 1 t plus 2 raised to n minus 1 t. It is a, can we take it as 2 into 2 raised to n minus 1 t. Can we use that one? Yes. Can we use this 2 raised to n minus 1, 2 into 2 raised to n minus 1 into t, 2 raised to n plus 1 minus 1 minus 2 into t. This minus 1 can be negligence. The continuous time equals to, the continuous time equals to of ADC equals to 2 raised to n plus 1 into t. The continuous time period equals to 2 raised to n plus 1 into t. The what is the advantages of this one is dual slope integrated type of ADC is main is accuracy. ಅಕ್ಯುರಸಿ ಇಫ್ ಯು ಅಕ್ಯುರಸಿ ಕೊಡ್ತಾ ಇದೆ ಅಂದರೆ ಇದು ಭಾಳ ಟೈಮ್ ತೊಗೊಂಡು ಕೊಡ್ತಾ ಇದೆ ನಮಗೆ. ಹಾಗಾಗಿ ಇದ್ರದ್ದು ಡ್ರಾಬ್ಯಾಕ್ ಅಂದರೆ ಇಟ್ ಟೇಕ್ಸ್ ಟು ಮಚ್ ಆಫ್ ಟೈಮ್. It is the main use of that one. Less of cost, slow speed, and accuracy will be more than the other kind of the ADCs. Yes, that is the main important of the dual slope A to D converter. Next is a flash A to D converter. Next, it is a flash type A to D converter. One more name of this flash type converter can be used it as a parallel type ADC. The one more name of the flash converter is ADC. Parallel type ADC can be called it as. This ADC is converted IC also called as a parallel ADC. Yes, which is the most widely used in efficient and ADC. This flash converter is a very fastest converter comparatively all the ADCs. Yes, this is used for if you know the priority encoder of the 8 is to 3 bits. Yes, that is the priority encoder. If you heard this one is correctly, you can use it very easily. Priority encoder truth table I'm going to see you once again. This is the 8 is to 4 8 is to 3 priority encoder. If it is a y0 is 0, the all are zeros, and y1 is 1 and the a0 is 1. That is the whole thing. Y2 equals to 1 0, y3 equals to 1 1, y4 equals to 1 0 0, y6 equals to y5 equals to 1 0 1, y6 equals to 1 1 1 0, y7 equals to 1 1 1. This is the output. Have you seen that one? They can use for this one in the flash or parallel type ADC. This is the circuit of the flash type of that one. This is the reference voltage V, and if Vin is greater than this one is a Vin input voltage Vin here, it connects to the all the comparators. This one is a all the positive comparator. Positive comparator converted to V reference. Inverting terminal connects to the inverting terminal connects to the V reference, and non-inverting terminal connects to the V in. Yes, in this way, V in is greater than V reference. Op amp is high. Op amp is high. If V in is less than V reference, it is a op amp is 0. Op amp is 0. This is the registers can be used 1, 2, 3, 4. It is the register number is 2 raised to the power n. The op amps are lesser than this one, 2 raised to n minus 1. And the registers 5 ಇದ್ದರೆ op amps ಎಷ್ಟಿರಬೇಕು 4 ಇರಬೇಕು. ರೆಜಿಸ್ಟೆನ್ಸ್ 8 ಇದ್ದರೆ op amp ಎಷ್ಟಿರಬೇಕು 7 ಇರಬೇಕು. This is the way of that one can we get it. For example, ಔಟ್ಪುಟ್ ಹೆಂಗೆ ಡಿಸೈಡ್ ಆಗುತ್ತೆ ಅಂತಂದರೆ ಇಟ್ ಈಸ್ ಡಿಪೆಂಡ್ಸ್ ಆನ್ ದ ಕನ್ವರ್ಟರ್ಸ್. ಇಟ್ ಈಸ್ ಅ ಡಿಜಿಟಲ್ ಟು ಎನ್ಲಾಗ್ ಕನ್ವರ್ಟರ್ಸ್. This is in the comparator in the flash digital converter circuit consisting of the series of the comparator, which is the compares the input signal with the unique reference voltage at each comparator. The output will be the high state when the analog input voltage exceeds the V reference. And ಏನಾಗಿರ್ತದೆ V in is greater than V reference ಇದ್ದಾಗ op amp ಹೈ ಇರ್ತದೆ. ವಿ ಇನ್ ಈಸ್ ಲೆಸ್ ದೆನ್ ವಿ ರೆಫರೆನ್ಸ್ ಇದ್ದರೆ ಆಪ್ ಆ್ಯಂಪ್ ಏನಾಗಿರ್ತದೆ, ಝೀರೋ ಇರ್ತದೆ. ದಿಸ್ ಈಸ್ ದ ವರ್ಕಿಂಗ್ ಕಂಡೀಷನ್ ಆಫ್ ದ flash encoder. Yes, this is generally a binary code based on the higher order input active, ignoring the other active inputs. The flash trap is a high cost, high speed, and device. This is the very takes the too much of space to soldering that one. It is takes the very lengthier fabrications. This is very lengthier fabrications comparatively other ones, but this is the speed is very higher than the other ADCs. This is the main advantages of that one. This is the very speed. Yes. Next one is a successive approximation A to D converter. The successive approximation of the A to D converter. Let us see in the next sessions this one. Okay, thank you. Please watch our videos regularly.